Okay, everyone. So I guess everyone remember the concept till last point. Okay. 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 Next concept. I hope all of you remember the next concept was energy. Yes or no? Tell me. Energy in wave motion. Wave motion. How many of you remember this concept? Tell me, guys. How many of you remember this concept? Think about it. Obviously, whenever we talk about motion, right, the particle is moving. If particle is moving, there is energy associated with that. Yes or no? Tell me. हाँ या ना? अब तुम खुद सोचो ना, तुम खुद सोचो, मान लो एक थ्रेड है, right? Suppose you have a rope and you want a pulse to be created. तुमको यहाँ से उसको ऊपर फोर्स लगाना पड़ेगा. Yes or no? हाँ या ना? Right? Yes. So if we apply a force, ये particle ऊपर जाएगा, जाएगा कि नहीं जाएगा? जाएगा. Now, if this particle is moving up, force is also in this direction. We are applying or we are doing work on this. Work is being done. Clear है? So work done तो हो रहा है. Work is being done. Right? बहुत basic concept है. Work is being done. किसी को दिक्कत है यहाँ तक में? है ना? And that work is converted into energy, right? So obviously this energy will be there. Okay, right? Now let's talk about some term before starting this. The first term is something called energy density. Energy density. Now what is energy density, guys? Tell me, what is energy density? क्या लगता है? Tell me. Yes, very good. Energy per unit volume. Yes or no? Tell me, yes or no? Right? Now, if I talk about energy density, right, we will always talk about energy density here. Okay, in waves, we will generally talk about energy density. Okay, so this is energy per unit volume, right? ठीक है. Now, I hope all of you know kinetic energy, potential energy. उसके लिए किसी दिक्कत नहीं है ना? ये तो सबको पता होगा kinetic energy क्या होता है, potential energy क्या होता है, right? Okay. Now, let's talk about individual energies, right? Let's talk about kinetic energy per unit volume. Per unit volume, which is the kinetic energy density. Now think about it. What is the formula of kinetic energy, everyone? Tell me. I hope सबको पता हो यहाँ पे. What is the formula of kinetic energy? Tell me, what is the formula of kinetic energy? और kinetic energy यहाँ पे किसका होगा? First of all, sir, kinetic energy किसका? Particle move कहाँ कर रहा है? Particle is moving in which direction? Tell me, everyone. Particle, if you talk about particle moving in y direction. Yes or no? Yes, SHM ka. Yes, Anurag, very good. Right? So the kinetic energy will be of this particle which is moving in up and down direction, y-axis, right? So the velocity that we will be considering is Vy. Yes or no? Yes or no? Right? And we know that the formula of kinetic energy is equal to half mv squared. Agree, everyone? Tell me, agree? Yes or no? Right? Yes. So let's divide both term, which is Vy. I'll just write out Vy. Let's divide both term by volume. Okay. So this will be kinetic energy density. We will always talk about kinetic energy density. Okay. So I'll write it as delta K, right? It's energy per unit volume. Okay. Right? Now this is equal to half mass by volume into Vy square. Step by step. यहाँ तक मुझे दिक्कत है? Tell me, यहाँ तक में किसी को दिक्कत है? Anyone have any doubt in this? Now we have discussed the formula would be same as this SHM. How many of you remember? हाथ उठा लो. कितने लोगों को पता है कि formula exactly same हो जाएगा? Half rho. Now Vy, we know that. What is V? What is Y? y is equal to a sine omega t minus kx, yes or no? And vy is dy by dt whole square, right? If you put the value of v, or you can just say vy is equal to a cos omega t minus kx, ठीक है, स्टेप बाय स्टेप। तो क्या हो जाएगा, हाफ रो a स्क्वायर ना ओमेगा, सॉरी ओमेगा भी होगा, ओमेगा स्क्वायर cos स्क्वायर ओमेगा t माइनस kx। याद है सेम फॉर्मूला था एसएचएम का, राइट? एसएचएम का सेम एनर्जी था ये, बिकॉज व्हेन यू टॉक अबाउट काइनेटिक एनर्जी इट इज एक्चुअली द एनर्जी ऑफ एसएचएम, राइट? एनर्जी ऑफ पार्टिकल moving in SHM motion. Anyone have any doubt in this? Same formula again, tell me. Kinetic energy per unit volume is given by half rho a square omega square cos square omega t minus kx, right? Same as SHM. Yes or no? Tell me yes or no. Right? Okay. Now I hope kinetic energy density समझ में आ गया. Now when we talk potential energy, let's talk about this. Delta U, potential energy. So I hope everyone know what is potential energy. Tell me, raise your hand. What is potential energy? Tell me. नहीं नहीं अनुराग, यहाँ पे तुमको ध्यान देना है, यहाँ पे तुमको ध्यान देना है, बिकॉज राइट यहाँ पे ना, यहाँ पे सेम नहीं होगा. थिंक अबाउट इट. व्हाई? इट इज एक्चुअली द वर्क डन, बेसिक फॉर्मूला पुटिंग गेटिंग वर्क डन, यस और नो, जो हम लोग ड्राइव किया था. इट इज बेसिकली वर्क डन इन स्ट्रेचिंग द स्ट्रिंग. यस और नो? टेल मी यस और नो. राइट? सो देखो, जैसे तुम यहाँ पे स्ट्रिंग को स्ट्रेच कर रहे हो तो स्लोप चेंज हो रहा है ना. यस और नो? स्लोप चेंज हो रहा है, राइट? यस. Okay, so can I say that the potential energy, think about it, the potential energy of the spring, right? Okay, per unit volume is given by what? I'll just use one basic formula, just half rho v square into dy by dx whole square. Okay, right? This is the basic formula. तुमको बाद वाला formula पता है, बाद वाला formula तुमको पता है. I'll just do that, right? But you do remember that formula. Okay, if you know that y is equal to a sine omega t minus kx. I hope all of you remember this. Then dy by dx is equal to what? A, tell me, a square, k square, sorry, a into k, no, a into k, because integration of this, right, with negative sign, cos omega t minus kx. ठीक है? Now put it over here, put it over here. Half rho. What is v, guys? What is v? How many of you remember? V is equal to omega by k. It is omega square by k square. Yes or no? Into dy by dx whole square, which is a square k square cos square omega t minus kx. Yes or no? Tell me. Now this is the difference. This is the difference. If you remember SHM, यहाँ पे क्या था? Sin square था. Yes or no? Tell me. Yes or no? समझ में आ रहा है? Yes or no? Right? क्योंकि यहाँ पे पार्टिकल x एक्स में मूव कर रहा है, right? The difference in this expression is because it is not SHM, it is the wave. The energy is stored in a wave, right? Think about it, है ना? It depends on slope at individual points. यहाँ पे slope change हो रहा है. Because of this change in slope, there is change in configuration, right? Okay, there is change in work done, and because of that, the expression is this. Okay, right? So I'll just use red pen. तुमको directly बस ये last वाला याद करना, k square cancel. So this, I hope all of you remember this, जो तुमको याद होगा, rho omega square a square cos square omega t minus kx. Now, don't you think that this delta U is same as this? Tell me, how many of you remember this? Right? Again, per unit volume. This is per unit volume, right? My bad, per unit volume. Don't you think that these two are same? Yes or no? समझ में आ रहा है? ये difference है, right? Here, kinetic energy per unit volume and potential energy per unit volume is same. Okay, right? So if you want to find total energy per unit volume, it is what? Kinetic energy per unit volume plus potential energy per unit volume. Okay, so it is half rho square omega square a square cos square omega t minus kx plus same half rho square omega square a square cos square omega t minus kx. हाफ प्लस हाफ कितना होता है? हाफ प्लस हाफ इज 1 ना, हाफ प्लस हाफ इज 1. तो ऐड कर दो कितना हो जाएगा? सिर्फ रो स्क्वायर ओमेगा स्क्वायर ए स्क्वायर cos स्क्वायर ओमेगा टी माइनस kx. Tell me yes or no. So this is what? This is total energy per unit volume. Yes or no? Tell me yes or no. And this is actually known as total or just energy density. ठीक है? Yes or no? Tell me yes or no. Tell me. Now, how many of you remember what is the average value? What is the average value of cos square theta? Tell me, guys. What is the average value of cos square theta? हाथ चालो. बताओ. किसको याद है? Average value of cos square theta किसको याद है? Tell me, guys. Average value of cos square theta? Very good. 1 by 2. है ना? 1 by 2. I hope all of you remember average value of cos square theta is 1 by 2. Right? है ना? So if I want to find average energy density, so I'll just use that U, small u, chotka u is total energy per unit volume. Average U is equal to what? Tell me. Now, cos square theta, the average value is half, and rho square omega square a square. Got it? Tell me, got it? Yes or no? सबको समझ में आ रहा है ये? इक्वेशन से समझ में आएगी नहीं? हम लोग इसको विजुअलाइज करेंगे, बट इक्वेशन से समझ में आएगी नहीं? टेल मी. First, let's understand this, then we'll talk about individual positions, right? Okay, so let's see. I hope यहाँ तक सबको समझ में आया होगा. किसी को नहीं समझ में आया पूछ लो. किसको दिक्कत है? श्रेया, चुलिका, खुशी खुशी, स्नेहा, everyone? Anyone have any doubt till this point? Right? So यहाँ पे तुम्हारा सवाल है, sir, right? Usually in SHM we studied that kinetic energy, potential energy अलग अलग था, है ना? जो kinetic energy zero, potential energy maximum and all those things. But यहाँ पे ऐसा नहीं है. यहाँ पे same time पे होगा. Yes or no? Phase are actually same. How this is possible? So we will just visualize. Let's see. Let's visualize. ठीक है? हम लोग देखते हैं. Right? We will just visualize. Right? Let's have a wave like this. Okay. Now think about it. Let's take this point A. Let's take this point A. This is point A. This is point B. है ना? This is point B. Now, what is the phase of point A? Everyone, tell me, what is the phase of point A? Tell me. Pi by 2. Very good. So phase, which is omega t minus kx, is equal to pi by 2. Anyone have any issue in this? Anyone have any issue in this? Right? So if you talk about this, so we know that, sir, the formula of kinetic energy is what? Half rho omega square a square cos square. Now this whole term I'm just writing as phi, right? This whole term I'm writing as phi. So if phi is 0, so this will be 0 at point A. It will be 0. Yes or no? Kinetic energy will be 0. Agree. And potential energy is same as kinetic energy, same formula. So this is also 0. Yes or no? right? Okay. ठीक है? Now, what about point B? What about point B? Tell me, what about point B? Tell me. Tell me. यहाँ पे तुमको बस ध्यान ये रखना है ना कि एनर्जी, पोटेंशियल एनर्जी in case of wave, right, depends on depends है ना displacement, yes or no? I hope all of you remember, yes or no? SHM में displacement पे डिपेंड करता था. Potential slope. Now tell me, what is the slope at this point? Don't you think that slope is zero? Tell me, don't you think that slope is zero? Yes or no? Right? If the slope is zero, right, potential energy is zero, right? What about B point? At B point, velocity is maximum because the and slope is also visualization energy. Vas, Shriyari, Sneha, Priyanka, Nishita, Koshi, Khushi, Chulika, everyone. स्टेप बाय स्टेप समझ में आ रहा है? ये कॉन्सेप्ट समझ में आया कि नहीं? ये बहुत इंपॉर्टेंट कॉन्सेप्ट है, बहुत लोग गलत करते हैं, ठीक है? ओके, नाउ आई होप एनर्जी अंडरस्टूड, एनर्जी इज क्लियर. नेक्स्ट इज पावर. नेक्स्ट इज पावर. नाउ आई होप I've already discussed what is power. बताओ पावर का मतलब क्या होता है? What is power? What is the basic definition of power? It's an instantaneous rate at which energy is transferred. So this is basically energy, yes or no? Rate of, right, instantaneous rate at which energy is transferred. Agree? Tell me, agree? Right? Okay. So what do you think? What would be the formula? Tell me, what would be the formula? Tell me. Step by step, step by step. सोचो एक बार. सब कुछ सोचो एक बार. What do you think? What would be the formula of power? So I can say, sir, power is what? Power is energy per unit time. बहुत बेसिक, बहुत बेसिक सर, ये हमें पता है, ये हमें पता है, ठीक है सर. आप बताओ और आगे क्या करेंगे? सो यहाँ पे एनर्जी की जगह हम मान ले रहे एनर्जी डेंसिटी. इफ आई एम टॉकिंग अबाउट एनर्जी डेंसिटी, so it is energy density per unit time into volume. Yes or no? Tell me, yes or no? Step by step. Yes or no? Okay, right? Now think about it, think about it. यहाँ पे बहुत इंपॉर्टेंट कॉन्सेप्ट है. अगर मैं यहाँ पे फॉर्मूला डायरेक्टली लिख दूं, अगर मैं फॉर्मूला डायरेक्टली लिख दूं और टाइम मैंने 1 सेकंड ले लिया, टाइम इज इक्वल टू 1 सेकंड मान लो, राइट, टाइम 1 सेकंड ले लिया मैंने, ठीक है? सो मैं डायरेक्टली फॉर्मूला क्या लिखूंगा? हाफ रो ओमेगा स्क्वायर ए स्क्वायर विच इज यू, है ना, विच इज यू, राइट, इनटू now what is this? What is volume? Tell me, what is volume? Tell me. V. Clear है? Now this is the formula of power, but my question is this your average power or instantaneous power? देखो ये सब कॉन्सेप्ट ध्यान रखना है, ये एवरेज पावर की इंस्टेंटेनियस पावर है. बताओ, हमेशा तुम लोग पावर रख लो, ये फॉर्मूला है, बट ये कौन सा पावर है, एवरेज की इंस्टेंटेनियस? एवरीवन थिंक अबाउट इट. इज दिस योर एवरेज पावर और इंस्टेंटेनियस पावर? Yes, very good, Ovas. It is your average power, right? Because see, the formula, this formula is of average energy density. Yes or no? Average energy density. Clear? Tell me, clear? Yes or no? Okay. Now, I hope all of you remember the very basic formula of power in one more term, which is F dot V, or sorry, F into V. F into V. Yes or no? Tell me, F into V. Yes or no? सबको याद है ये? सबको याद है? This is the very basic definition of power. Basic definition. Okay. Now, अगर मैं इस फॉर्मूला को यूज करता हूँ, I want to find instantaneous power. Sir, instantaneous power क्या होगा? Average power तो आपने बोल दिया. If I have to find instantaneous power, tell me, right? Okay, instantaneous power. Then what? Then don't you think that I can use this formula? Because instant means at a function of x and t, yes or no, power at time t and position x. That is the meaning of instantaneous, na? That is the meaning of instantaneous, yes or no? Usi time pe, usi jagah pe, right? So I can say, okay, sir, this should be a function f. Now, when talk power, it is of particles, fy, at that time and that moment, okay, into velocity of particle, because power to particle ka hi denge na, at that point and that time. Yes or no? Tell me, yes or no? Right? Okay. Now, if you find the value and put it, right, you will get this expression. I'm not doing it because तुम लोगों को जरूरत नहीं हो, but पता होना चाहिए. ठीक है? It would be this: rho omega square a square into volume into capital V volume sine square omega t minus kx. Okay. और cos स्क्वायर ओमेगा टी माइनस के एक्स. ये बस डिपेंड करता है तुम्हारा माइनस माइनस. तुम इनिशियल फंक्शन कौन सा लियो? ठीक है, इनिशियल फंक्शन कौन सा लियो? अगर इनिशियल फंक्शन तुम साइन लियो तो साइन आएगा, इनिशियल फंक्शन अगर तुम ये लियो तो ये आएगा. ठीक है ना? डोंट यू थिंक दिस इज करेक्ट? डोंट यू थिंक दैट दिस इज करेक्ट? राइट? यहाँ पे हम लोग कॉस ले रहे हैं तो ज्यादा कंफ्यूजन नहीं होता है. हम लोग यहाँ पे कॉस ही लेते हैं. ठीक है, राइट? लेट्स टेक कॉस ओनली. Okay, don't you think that this is correct? Because if it is instantaneous, then the average will be the average of cos square this, which is equal to half. If you relate this on this, you will get this expression. Yes or no? Tell me, yes or no? Clear? Tell me, clear? सबको समझ में आ रहा है? यहाँ तक सबको समझ में आ रहा है? किसी को दिक्कत है पूछ लो. राइट? किसी को दिक्कत है यहाँ पे पूछो. है ना? हम लोगों ने बेसिक देखा. दिस इज योर इंस्टैंटेनियस पावर, पी इंस्टैंटेनियस. Instantaneous. So this is instantaneous power, this is your average power. Okay, right? कभी कभी पूछ लेता है ना, कभी कभी पूछ लेता है. ठीक है, कभी कभी पूछ लेता है. Now, after power, the next term is intensity. Intensity. I hope all of you remember intensity, which is basically what? Power per unit area. है ना? अब तुम लोग को ये फॉर्मूला क्लियर हो रहा होगा. Yes or no? Tell me. अब तुम लोग को ये फॉर्मूला क्लियर हो रहा होगा. Right? नाउ यहाँ पे एक और मॉडिफिकेशन मैं कर रहा हूँ. ठीक है, ध्यान दो. यहाँ पे एक और मॉडिफिकेशन कर रहा हूँ मैं. मान लो कि टी एस सेकेंड ना लेकर 1 लेता हूँ. ठीक है, सो वॉल्यूम, दिस वॉल्यूम कैन बी रिटन एज, वेट आई जस्ट एडजस्ट इट. ठीक है, ध्यान दो. दिस वॉल्यूम कैन बी रिटन एज व्हाट? एरिया इनटू लेंथ. यस और नो? राइट? एंड दिस टी इज बाय टी. यस और नो? टेल मी, यस और नो? राइट? सो दिस लेंथ बाय टी इज नथिंग बट, tell me, velocity v. Yes or no? And this length is this length in x direction, right? So this is your wave velocity. Got it? This is your wave velocity na, right? है कि नहीं? So I can write half. मैंने बस मॉडिफाई कर दिया. ओमेगा स्क्वायर a स्क्वायर. ठीक है, right? wait, sorry, A is also used for this na amplitude na, so I'll just use S, surface area S, ठीक है, into S into V. क्लियर है ये चीज? टेल मी, क्लियर है ना? राइट, ठीक है अनुराग, बाकी सब है ना? सो टाइम 1 सेकेंड ना लेकर, दिस इज वॉल्यूम पर यूनिट टाइम, वॉल्यूम पर यूनिट टाइम, वॉल्यूम पर सेकेंड, वॉल्यूम पर सेकेंड, ठीक है? सो वॉल्यूम पर सेकेंड कैन बी रिटन एज एरिया इनटू स्पीड, ठीक है? राइट, मैंने वो लिख दिया है, राइट, ओके, राइट, ठीक है? वी कैन जस्ट मॉडिफाई द formula according to what is given. Now, if you talk about intensity, I hope सबको intensity का formula याद होगा, हमने पढ़ा था, हम आज drive कर रहे हैं. Power का formula क्या है? Average power. We'll just talk about average power itself. Okay. So half rho omega square a square s into v. Now this is wave velocity by area, which is s. So s cancel हो गया. बताओ s cancel हो गया. तो क्या आ गया तुम्हारा? Half rho ओमेगा स्क्वायर ए स्क्वायर वी. ये फॉर्मूला याद है? यही फॉर्मूला था ना इंटेंसिटी का? टेल मी एवरीवन, यही फॉर्मूला था इंटेंसिटी का? यस और नो? टेल मी यस और नो. राइट, यस, ओके. सो हमारा ये वेव का कॉन्सेप्ट क्लियर हुआ है, सारे वेव का कॉन्सेप्ट क्लियर हुआ है. अब छोटा मोटा थोड़ा सा और टर्म से वो जान लेते हैं, बट इंटेंसिटी क्लियर हो गया सबका? किसी को दिक्कत है इंटेंसिटी, पावर, एनर्जी, वेलोसिटी में? किसी को दिक्कत है यहाँ तक में? Anyone have any doubt till this point? Please ask. Tulip, Sneha, Shreya, Ronak, Riya, Priyanka, Pritam. फॉर्मूला बस याद होना चाहिए, ठीक है? राइट, आप डिराइव की कैसे कैसे है, ताकि अगर कोई डिफरेंट काइंड ऑफ प्रॉब्लम्स आए जहां पे तुमको फॉर्मूला ड्राइव कर देना पड़ जाए, या तुमको पता नहीं चले कि कैसे करना है, इंस्टेड ऑफ वेलोसिटी तुमको वॉल्यूम दे दिया जाए, तो तुम पता लगा सको कि कौन सा फॉर्मूला कैसे आया है, ठीक है ना? आफ्टर दिस, राइट, I hope all of you know about phase difference, path difference. सबको पता है ना ये चीज? Phase difference is delta phi, path difference is delta x, right? And we know that when you talk about phase difference and path difference, okay, there's a relationship which is delta phi is equal to what? Tell me everyone. 2 pi by lambda. Okay, tell me 2 pi by lambda into delta x. इसका डेरिवेशन याद है सबको कि मुझे करना पड़ेगा फिर से? बताओ, टेल मी. आई होप ऑल ऑफ यू रिमेंबर ना दैट phi 1 is equal to omega t minus kx1, phi 2 is equal to omega t minus kx2. Assumption is t is same, but if t won't be same, then there will be different formula. You can derive using this expression only. Then phi 2 minus phi 1 is equal to omega t will get cancelled, k is common, then x2 minus x1, right? So delta phi is equal to k delta x1 x, and k is equal to 2 pi by lambda. Yes or no? Tell me yes or no. Clear? Right? Anyone have any issue in this? Okay, okay, very good. Now एक last concept एक चीज बताओ. I hope all of you remember, okay, from last chapter, that v is directly proportional to root t, v is directly proportional to root t in gases. Yes or no? How many of you remember this? Tell me, याद है कि नहीं याद है? Now if I ask you, can you derive this? Tell me, can you derive this? Can you derive this now? मैंने थर्मोडायनेमिक्स में बोला था कि हम लोग बाद में देखेंगे, but can you derive this now? Tell me. Yes, very good, very good. See now, v is equal to root p by rho, है ना? Or you can talk about, this is in isothermal. Now we know that p is equal to what? Tell me, p is equal to what? Tell me. P by rho, pm is equal to rho RT. So p by rho is equal to RT by M, है ना? So if you replace this, we will get what? Root RT by M. Yes or no? Tell me yes or no. Clear? So yes, now I can say that velocity is distribution to root T. Okay, velocity is distribution to root T in gases. Okay, right? And in solid, it is inversely proportional to root T. So this marks the end of this first topic, which is just waves, about wave motion, right? All these concepts are just of wave motion. Okay, point one. So anyone have any doubt in this? Tell me, anyone have any doubt in this? समझ में आया? सबको समझ में आया? किसी को भी डाउट है पूछो. We have 10 minutes. किसी को डाउट है पूछो. Because in next class we will start, okay, we will start this. Okay, next topic.